derivative with the difference quotient. Then I started teaching you all these shortcuts, right? Which made it fast and efficient. Well, the derivatives start getting a little bit more advanced. They start getting a little bit more messier in algebra. So that's what you're going to find when we start working these out. So what I want to do to start with is show you this idea, then we'll go over what the product rule is. So this thing right here you've learned how to do. Okay, this is something that's real easy. You have learned, and you can do this in your head, but I want to just kind of review the rule that we learned, and you're getting to a point where you just start doing this in your head anyway. I don't always write this step out when I'm doing this, but you do the derivative of each part, right? Then you add it together. Well, what's the derivative of 3x? 3. So you got 3, 4, and 5, right? So you would end up having 3 plus 4 plus 5, so that's equal to 12. Okay, so that you could do the problem that way. The other way you could do the problem is you could do it like this. Well, these are all like terms, so that's 12x, right? So if you did the derivative of 12x, what is that? 12. So see, it works in this case. You can break up a derivative of a sum into the sum of the derivatives. So that's what we've been working on the last couple of weeks. But it's a little bit different if you have a product. So let me show you what happens on this then. So the question I'm asking you is, does the derivative of a product equal to the product of the derivatives? Okay, well, let's find out. Okay, first of all, let's do this way. What would, if you just multiply those two numbers, what do you get? X to the 6, right? Okay, you add the exponents because you're totaling how many x's we have. All right, so we got that. Now everybody's got this down. What's the derivative of x to the 6th? 6x to the 5th. Okay, that we know that's what that derivative is. Okay, well, let's see if it works this way. This is what I'm asking you. So let's go through and let's do the derivative of x squared, and then let's do the derivative of x to the 4th, then multiply it together. Let's do it kind of in a different order and see what happens. Okay, well, let's see. Derivative of x squared, 2x. Derivative of x to the 4th, 4x to the 3rd. So what do I get?
8x.
X to the 4th. Did it work? No, it doesn't work. Okay, and really never does. Okay, so the idea with this is you can't just go through and do the derivative of each part in that product and multiply them together. It doesn't work. What you have to do is you got to simplify it first and then do that derivative. Or we're going to learn what we call the product rule. Well, I'm trying to show you on this first example, it works for addition, but it doesn't work for multiplication. Does that make sense, what I'm saying? Okay, all right. So what we do on this is we're going to learn what we call the product rule today. And whenever you have two functions multiplied, when you're doing the derivative, the product rule is typically what you're going to use. Okay, so I'm going to show you this and kind of show you how you want to remember this. There's another derivative rule you're learning is the product rule. So what this says is if you have two functions that you're multiplying, f of x and g of x are just functions of x, then what you do is you take f of x times the derivative of g of x plus g of x times the derivative of f of x. You don't want to memorize it that way. You want to memorize these things in words. So this is the way I usually tell students to do this, is like this. It's just basically, and you can even write this down if you want to. This is the way I like to get students to, why don't you just write this down and just use f and s. F is the first function, s is the second function. Okay, I do this sometimes backwards the way textbooks do, but it doesn't matter. So what you do is you just write down the first, then you multiply by the derivative of the second. Then it's addition, you do plus, then you just do it backwards. Then it's the second times derivative of first. So if you learn it in words, you'll have it down pretty quickly. It's just the first, then derivative of second, plus second times derivative of first. If you learn it in words, you'll remember it a lot better than you will if you learn it in symbols. Okay? So I'm going to show you how this works. The derivation of this I just put on your notes. I'm not going to go through the derivation of this, but I did put it on your notes that you can look at if you're interested. So let's do the product rule on this. Okay, so first of all, We already know in this problem that that's x to the 6th. So the derivative is 6x to the 5th. Okay, we already know that. And that's the way you would do this problem, by the way. I mean, you'd be done in 10 seconds, right? You can do it in your head. What I want to do is show you how the product rule works. So it's a good idea when you're learning this to just write the formula down in symbols like that. That's a good way to learn that. So we're going to take this function and put it together like this. So the first is just going to be the x squared. The second function is just going to be the x to the 4th. Now we're going to do this one in our head, and I'll show you what happens. So the first is x squared, so you write that down. And then I'm going to have you put the symbol here. I'm going to have you put d dx of the second, which is x to the 4th, because you can do that in your head now and understand that. Then you do the second, which is x to the 4th, and then you multiply by the derivative of the first. Okay, so again, that's what you always do if you have a product. It's just putting the first, then this derivative, and then backwards. Second and that derivative. Okay, go ahead and take a minute and work it out and see if you get 6x to the 5th. It would not be the way I would do the problem. I'd do it in my head the way I've already showed you. But go ahead and finish it out and see if you tell me if you get 6x to the 5th. Does it work? Has anybody finished it yet? No? There's the calculus step, and then there's the algebra step on that. And if you do it right, you should get 6x to the 5th. Okay, that's how you start. Okay, you got your two derivatives. Okay, so what is this part right here going to be? 4x to the 5th, right? Okay, well, maybe some of the algebra that you got to review. That's 4x to the 5th, right? Okay, then it's plus this part right here is what? 2x to the 5th. Are those like terms? Yeah. Yeah, so 4 plus 2 is 6, so it does work. Okay, that's what I wanted you to try to do. Okay, it'll go through and it'll give you the same answer. So if you're doing a product, most of the time you have to use the product rule. Yes. Okay, then you would have to kind of pair together two of them and just treat that whole thing as one. Same thing. Same thing. Yeah, you would have to kind of group them together. Okay, you'll see that sometimes, but you're also later going to learn next week we're going to learn what's called the chain rule that'll help you a little bit with that situation too. Okay, all right. Any questions about what we just did? What you just did? Okay, all right. Okay, so on the next page of the product rule, I don't require you to know how to do this derivation. I just like to put it in here because I like to remind you that everything, all of these derivative rules that we learn, they all have to do with the difference quotient. Okay, and a mathematician, that's how they figured out the product rule, is doing that. Okay, that's something that's worth looking at, but I'm not going to go through that in class or anything, but that's where that comes from. Okay, so let's go down to the bottom of the page, and I'll kind of get you started on this. And we're going to do two methods. We're going to do the product rule, but we're going to do another way first. And sometimes it's better not to use the product rule. And that's what I want to show you. So let's go ahead on this one, and let's just multiply this out first. You want to make sure that you know how to handle the algebra okay on this. So we're going to do distributive property, and we're going to do that. Now, you can do all this in your head. I usually, when I teach this, like to kind of show the steps in this class so you make sure that you see what I'm doing. So I'm just taking 3x times x squared, and then that is 3x to the 3rd. You can just do it in your head. You don't have to write that intermediate step. Then I do 3x times 3x. So that's plus 9x to the second. Okay, then I do 3x times 1. And then that's plus 3x. Okay, be sure you pay attention to whether it's positive or negative when you do that. Then I just do the same thing with the 4. You're doing a distributive property, so that would be negative 4 times x squared. That's negative 4x squared. Then I do negative 4 times 3x. So that is negative 12x. And then the last thing I do is negative 4 times 1. So that's negative 4. Okay, that's the algebra that you want to review on then. Okay, what would you do next before we start doing the derivative? Yeah, combine the like terms. You want to do that. So your like terms are your x squareds and your x's, like that. Okay, so what we'd have here is you would have 3x to the third plus 5x to the second, and then minus 9x minus 4. Okay, now all we've done so far is we've done the algebra, so I'm just going to have you now do the derivative. Go ahead and do the derivative, and then you'll be done with the problem, and then we'll look at how this works with the product rule. Okay, anybody have any question about the algebra on that? Okay, I see that sometimes with some students having a little trouble with the powers of exponents and stuff like that. Anyway, tell me what the derivative is. 9x squared plus 10x minus 9, right? Okay, you want to have that down to a science by now, okay? Now, so that's the answer. So what we want to do is we want to do the product rule, and we'll get the same answer. All right, so I'm going to write it down. I think when you're learning this, it's not a bad idea to just write down in symbols the product rule. First times derivative of second plus second times derivative of first, okay? And again, it'll go like this. The first is just the first function. That's that first thing in parentheses. Okay, the second part is the second function, so it'll kind of go like that. And then you do derivatives. You can do some of this in your head, and I'm okay with that. I usually like students to just get it written down in the formula first. So you would write down 3x minus 4, and then times the derivative. I like to use ddx as my symbolism for the derivative, and the derivative of the second is x squared plus 3x plus 1, like that, and then do it backwards. Now you write down the second, but you don't change it, and then you're going to multiply by the derivative of the first, like that. Okay, so just get it set up in your rule, and then we'll go through and then we'll work out the derivative. We should ultimately get the same answer then. Does everybody understand? Does anybody have a question about how that's put in the formula? Okay, good with that? Okay, so here's what you want to do next is you want to go ahead and just bring down the 3x minus 4. You want to do the derivative of what I got highlighted in yellow there. So that is 2x plus 3, like that. Then you go to the next thing. You bring down the x squared plus 3x plus 1. What's the derivative of 3x minus 4? Okay, good. That's 3. Okay, so we got that. Now that's the derivative, but we do need to simplify that and multiply that all out to get that final answer. Okay, so let's see what happens if we do it this way. Right? What you're going to have to do is you're going to have to FOIL this. The first two get FOILed, so I'll just do this in my head. 3x times 2x is 6x to the second. 3x times 3 is plus 9x. Inside term, negative 4 times 2x is negative 8x. And then the last term, negative 4 times 3 is negative 12. Okay, like that. So that's the FOIL. Did I miss something?
No.
Am I good? Okay, you're making me worried. That's okay. That's okay. All right, sometimes I make mistakes. Okay, next thing I'm going to distribute it by 3. So that would be 3x to the second plus 9x. Almost messed up. Plus 3 like that. Okay, now you got like terms, so you want to put together the like terms and see what we get. So it looks like we have x squareds that go together, and we have all of those x's that go together, and then we have the numbers that go together. Okay, let's see if we don't get the same answer. Let's find out here. Okay, so 6 plus 3 is 9x squared, so that's good. 9 minus 8 is 1. 1 plus 9 is 10, so that's good. And then negative 12 plus 3 is minus 9. All right, are you impressed? No? Okay, let me ask you a question. Which way would you rather do the problem? Everybody always says the first way. I agree, and that's the way I would do that. Now, there's times when you have no choice but to use the product rule, but if it's easier to multiply out and do the derivative, then by all means, do it that way. Okay? Yeah, so I mean, if it's just a matter of multiplying and doing the derivative, that's the way you're going to do it. But you're going to be forced to use the product rule most of the time. Okay? So I just wanted to show you that works out regardless of which way you do it. Okay, any questions about what we did? Okay, all right. Okay, so let's see. I'm going to do a couple of more here, then I'll let you maybe work one of the or two of these out before we do a break here. Okay, so let's do this one. Now let's multiply this out. How do you multiply this out? Well, the safe way is to write it out twice in FOIL, right? Or you can do the shortcut. Okay, let's just go ahead and let's do this kind of the safe way for now. Then I'll go ahead and just quickly review the shortcut. So let's just multiply it out. Okay, so that's going to be your first term is 16x to the second. Outside term is minus 20x. Okay, inside term's the same thing, minus 20x. And then the last term is plus 25. Okay, so we got that. All right, now you got like terms, so you want to put the like terms together. So when you multiply that out, you would have 16x to the second minus 40x plus 25. Okay, and this is the way I would do this derivative. Later, next week, we're going to learn how to do this with the chain rule, which is even less work than what we're doing right now. Okay, now the derivative. I'm going to write, since it's y, I'm going to say y prime. So what's the derivative in your head? 32x minus 40, right? Okay, so what you're going to have here when you do that derivative, you have 32x minus 40. Okay, that's the way that you could do that without having to do the product rule. Just multiply it out, and once you get it multiplied out, it's pretty easy to do. Okay, okay, let's do the product rule on this one also, because that's what I'm trying to teach you. Okay, and I just kind of keep writing down that formula. When you're doing your homework, once you have that memorized, you don't have to write that formula down each time. Okay, so when we do that, the derivative y prime, we just take the first. And what's kind of interesting about this, is there any difference between first and second? No. No? Okay, they're the same. Okay, so what you would do is the first is 4x minus 5. Then you would do the derivative of the second, which also is 4x minus 5. And then we'd do the second, which is 4x minus 5, times the derivative of the first. Okay, so the first and second are just the same function because you were squaring that function anyway. So let's see if this works and gives the same answer anyway. Okay, so you would bring down the first. When you do the derivative of 4x minus 5, what's that? That's 4, okay. And you go over here, it'd be the same thing. You would have the 4x minus 5. When you do the derivative of 4x minus 5, that's 4 like that. Okay, now just multiply it out, add up all your like terms, and see if you don't get the same thing. Go ahead and finish it up from there and take a minute, and you'll see if you get the same thing or not. Okay, just distributive property and adding like terms. I think it looks like you'll get everything the same on this. Okay, yep, looks like it works out. So 16 and 16 is 32x and minus 40. Which way would you rather do that problem? Still the first way. That's what students always say. Well, you're going to change your mind next week because of the chain rule that you can do it like in 10 seconds. Okay? That'll help on some of this. So a lot of times we kind of continue to find other shortcuts. So that one, the first two examples I've done, the easiest way to do it is just multiply it out, then do the derivative. Now, on example 3, you don't have any choice at all but to do the product rule. That's because there's an e to the x in it. So it's not like foiling and stuff like that. Okay? So let's go ahead and let's do this one. All right? And with this one, again, I'm just going to write down the rule. So first times derivative of second plus second times derivative of first. Okay, and you want to put it in the rule. Now there is going to be some algebra on here that you'll have to work on a little bit too. So the first is just the x to the third. The second is the e to the x. So those are your two functions that are being multiplied. That's why we're using the product rule. Okay. So the first is x to the third. Just write it down. You can do this in your head, but I'm going to have you write down that you're doing the derivative of the second. Okay, then you do it backwards. The second is e to the x. And then when you do the derivative of the first, again, you can actually bypass the step I just did once you get the hang of how to do these, because you can do a lot of those derivatives in your head. Okay? Right, so here's what you would have. You would have x to the third. What's the derivative of e to the x? E to the x. Okay, got that. Then you bring the rest down. That's e to the x. And how about x to the third? 3x squared. Okay, so that is your derivative right there. Okay, now we're going to do some algebra with this, and I find a lot of times when you're doing, the calculus of the kind of derivatives you're going to do now, you might have more trouble with the algebra. So I want to talk about what I want you to learn how to do, and this is real important. So what we're going to do is we can actually simplify this a little bit. So what I want to show you on this is you want to think a lot about factoring, because a little bit later you're going to have to put these things in a factored form. Okay, so I usually kind of say, that's my first term, that's my second term. We're going to take common factors out. What do you see that's the same in both boxes? E to the x. E to the x comes out. Anything else?
3.
You have an x to the third, x to the second. What comes out?
X to the second.
X to the second, lower exponent, right? So that comes out. So you're going to pull that out. Okay. And when we do that, again, just doesn't matter what order, I'm going to pull out the x to the second, and then e to the x like that. Then I'll have my blank parenthesis like that. So you want to look for factors on these problems when you simplify these. Okay, now just try to do this in your head. What do you multiply this by so it turns into what's in the first box? Already got an e to the x. What does this need?
1.
Needs another x, right? Okay, x squared times x is going to give that, right? Okay, so that's going to give x here. And then how about the next one? Just kind of compare what you have. You already have an e to the x. You already have an x squared. What are you missing?
3.
Missing a 3. Okay, so what you would have is the x plus 3 like that. That's how you want to write your answer, is like that. So you want to think about factoring most of the time when you do these problems, because a little bit later when we get in the next chapter, you're going to have to do that. So you need to learn how to do that now. Okay, is there any question about that algebra? Okay, all right. So I'm going to let you do, I think, this one problem down at the bottom, and then I think we'll take a break up. But I want to give you a little time to do this. I do want you to do it both ways. Do it both ways. Start by just multiplying it out and doing the derivative, and then do the product rule. You should get the same answer. Okay, I'll walk around and see if you need any help. You can work together a little bit on this too if you get stuck, and you can compare your answers. You'll probably know you're right. If you get the same answer both ways, you've probably done it right. I'm going to shut this screen off while you're working on it. I'm going to go ahead and just do it real quick, and then I'll walk around and see how you're doing in just a minute. Okay, you got it right. Good. Yeah, you got it right. So if it works both ways, you got it right. Good job. Okay. You know what's going on? Did you come in?
Yeah.
I need to get your test on break. Okay.
Yeah.
Okay. Yeah, okay. I think you're ready to do the derivative now. And then I think you should be in good shape. I think you made a mistake, right? Oh yeah, that's this derivative here. What's the derivative of x squared? 2x. There's no 1. Okay. Got your FOIL, so you have x to the fourth, so you have that, minus 4x squared, plus 5x squared. I usually go like this, it's distributed. 1, 2, 3, 4. X squared times x squared times 5, negative 4. Okay, so it's like what you're doing is a distributive product. And you're doing that twice. That's a more logical order to put that in. Got anything? Yeah, you're on the right track. Yeah, now what you'd want to do is just do the derivative. Because you multiplied it out correctly. You did that fine. You did it good. You're good. Okay. You did that fine. Very good. You made a mistake in your FOIL. Okay, x squared times x squared is not 2x to the fourth, it's x to the fourth. That's easy to do. Okay. That's what you should get. I think everything else is okay. That's good. Got like terms, and then you're ready to put your derivative together. Yeah. It work both ways? Okay. All right, which way would you rather do it? You know. That's my question. I think we've all been that. That's good. Very good. You guys are doing great. All right, good job. Got it? You got it? Very good. All right, outstanding. All right, man, we're awesome here today on this one. Okay, so let me just put this up here and see if we got any questions on this. So I got 4x to the third plus 2x. Okay, multiplied out. The first way is the easier way to do it. That's the product rule way right there. If you didn't get that, doing that the product rule, then you want to go over that. So again, on this product rule, I just take the first times derivative of second, which ultimately gives you x squared minus 4 times 2x. Then backwards, you do the second times derivative of first. So that's how the product rule works. That's what you're learning that's new to you. Okay? Almost everybody, I think, got that. There's just a few little mistakes on there. Okay, any questions about anything? Okay, let's go ahead and break now until 11 o'clock. I'll give you a break till 11 o'clock. If you got any questions about grade or anything like that, you can come up during break. And I'll be available after class today, too. Okay, we'll go ahead and finish. We really look at two things. So we've kind of worked on the product rule a little bit, and then we're going to go to the quotient rule. All right, so I'm going to do kind of the same thing. So the question I'm asking you that we're going to find out is, will the derivative of a quotient, that you're dividing, be equal to the derivative of the numerator divided by the derivative of the denominator? Okay, well, that's what we're going to look at, because I see students do this a lot of times. First of all, if you simplified x to the fifth over x to the third, what is that in your head?
X squared.
X to the second. Okay, well, make sure you review these exponent rules. You subtract the exponents. You don't need to write this down, but a quick reminder, all this means is you have some cancellation, you're left with 2. Okay, there's 2 more on the top. That's the way I think of that. So what you would have is you would have derivative of x squared, and that would be 2x. Okay, that would obviously be the easy way to do that problem, is to do it like that. Okay, so the question I'm asking you is, what would happen if we just did the derivative of the numerator, x to the fifth, and divided it by the derivative of the denominator? Would we also get 2x? So let's find out if that works or not. Okay, well, the derivative of the numerator is 5x to the fourth. derivative of the denominator is 3x squared. Does that look like it's going to be the same? No way, not even close, okay? So x to the fourth over x squared, what is that? X squared, okay? So you'd end up with 5x to the second over 3. So notice, yeah, you got a totally different answer. It doesn't work. So it doesn't work when you do a product, and it doesn't work if we do a quotient either. So we had to develop a new rule that we call the quotient rule. So that's what we're going to work on next, is how to do a quotient. The thing about the quotient rule, there aren't too many shortcuts. Like the product rule I showed you, you can multiply out, and it's usually easier to do it that way. Can't really do much on the quotient rule. You just have to kind of deal with it, okay? All right. And this gets into fractions and stuff, so these problems sometimes you got to work on a little bit on your algebra skill. All right, so let me show you what the rule is and how you should remember it. It looks kind of complicated at first. So when you're doing a derivative of f of x over g of x, what you do is you take g of x and then you do the derivative of f of x, and it's minus. Then you do it backwards, f of x times derivative of g of x. Then you do g of x squared. Yeah, you'll memorize that. You will. There's no student that, if you do your homework, you'll get it down fine. It may take you a while, but you'll get it. I think you're better off to learn derivative rules in words. Okay, so the way I usually show students is just like this. You take the bottom times derivative of top minus top times derivative of bottom. That's kind of similar to the product rule. Then it's the bottom squared. Okay, so like in symbols, a lot of times you'll see me write it as b t prime minus t b prime over b squared. Okay, that's how the quotient rule works, and the mathematical proof or derivation of that comes from the difference quotient like we learned. I think I put that on your notes. I'm not going to go over it, but you can look at that proof that I put on there if you're interested in looking at that. So that's the idea. That's what we're going to learn how to do is the quotient rule. Okay, so you just follow what it tells you to do, and if you do all your algebra right, you'll be fine. Okay, the algebra gets kind of messy on these things. This is the proof. I don't require you to know this in this level of a class, but if you want to look through it and see if you understand that, you're more than welcome to do that. Okay, so if you don't have enough to do on the weekend, look at that. That's a good one. All right. All right, so let's go to the next page. Okay, so if we've already did this problem. I want to do this with the quotient rule, though. So let's, again, just do this the easy way to start with. So if you have x to the fifth over x to the third, you know that's x squared. So what's the derivative? 2x. Man, boom, we're done in like 10 seconds. All right, so I'm going to show you how the quotient rule goes, because you have to know how to do the quotient rule. And let me just write this down. I would recommend you just write this down in symbols. So it's the bottom times derivative of top minus the top times the derivative of the bottom all over the bottom squared. So we're just going to do what the quotient rule tells us to do then when we get our derivative y prime. Okay, so I'll kind of go like this. The bottom is x to the third. So that's going to go there. The top is the x to the fifth. So we're going to put those things in there. Now what I recommend you do is just put it in the quotient rule, then do your derivative, and then usually the more advanced part for students is the algebra that's involved in this. So let's start by just write down the bottom. That's x to the third. It's good to write down that you're doing the derivative of the top before actually doing it. That's what I would like you to do. And then do it backwards. Do the top, which is x to the fifth, and then times the derivative of the bottom. So we'll write that as derivative of x to the third, like that. Then it's going to be all over the bottom squared. So you want to write that like that. So you want to always take the time to get that in the quotient rule formula before you actually start doing the derivatives. Okay, there's going to be some algebra issues that you're going to have to really pay attention to on this sometimes too. All right, so let's go ahead and let's see what we can do. I'm going to highlight, we're going to do those two derivatives. You just do the two derivatives. Take your time when you write the steps out. So just bring down the x to the third. What's the derivative of x to the fourth, or x to the fifth? 5x to the fourth. And x to the third? 3x squared. Okay, so just do those. Okay, so I'm going to write that as x to the third times 5x to the fourth, and then minus x to the fifth times 3x to the second, like that. Boy, I see students do this all the time in this class. If you do x to the third to the second, is it x to the fifth or is it x to the sixth? X to the sixth. You multiply exponents. The meaning of this problem is this. It means x to the third multiplied by itself. So you would have 6x's if you wrote that all out. Okay, so you don't get those rules mixed up. So that's going to be x to the sixth like that. Okay, right? Well, now what we're going to do is you can multiply these two parts there that I'm highlighting, and you would end up having 5x to the seventh there. Here you would have 3x to the seventh, all over x to the sixth like that. So there's basic algebra a lot with the exponent rules. Can you do anything with the top? Yeah, that's like terms. So that would be 2x to the seventh over x to the sixth like that. Okay. Is that going to give you 2x?
No.
Yeah. Okay. What's x to the seventh over x to the sixth? That's x to the first because you subtract exponents, right? So that would just be, you remember, you're subtracting the exponents. So that's 2x to the first. Okay, which way's the easy way? Obviously the first way, yes. But that kind of is a good way to show you that the quotient rule works. Most of the time you have no choice but to use the quotient rule. Okay, so that's the idea. That's what we're going to work on. The rest of this section is just mostly kind of getting this down, and then we'll do a couple of applications. Okay, all right. So when we go down to this next one, you have no choice but to use the quotient rule. Okay, you got a quotient, and you have two functions. The top part is the 3x plus 5, and the bottom part is the x squared minus 3. Okay, so what we're going to go ahead and do on this is I'm going to go ahead and write down the quotient rule. You don't have to do that every time you do the problem, but it's kind of helpful when I'm teaching this to write down what that rule is. So what we want to do first is we want to go ahead and just put this in the rule. So we got f prime of x, and just write it down. So the bottom is going to be parentheses x squared minus 3. You're going to do the derivative of the top. I would like you to write it down as d dx of 3x plus 5 before you do the derivative. Okay, then just kind of do it backwards. So now it would be the top, 3x plus 5, and then times the derivative of the bottom. And then that would be all over the bottom squared like this. So get it set up. Now make sure you get everything written in there, your parentheses and all that written out correctly. And then, and really once you do the derivatives, then you'll be done. And then you got to start thinking about what algebra exists in the problem then. Okay? Does everybody understand okay how I'm just setting it up? That's the first thing you got to learn is how to set it up. Okay? All right? So let's see. This derivative is 3. That derivative is 2x. Okay, so the next step, we just need to write that result down of those two derivatives. So we would have x squared minus 3 times 3 minus 3x plus 5 times 2x all over x to the second minus 3 to the second like that. Okay, now the calculus is officially done. That's usually not the part that students struggle too much with. The next part's the algebra. So I'll talk about kind of what goes on this. So what you want to do on this is just basic things. You want to multiply those two things out. Those are distributive properties. So you want to do that. And I'll tell you the thing that you have to be really careful about is that minus sign right there, because that's what I see more often than not is students not paying attention to that subtraction symbol in the quotient rule. So you have to pay attention to that. Okay, so I'm going to do this. I'd have 3 times x squared is 3x squared. I'd have 3 times 3, that's a minus 9. Be careful about your signs there. Now this is the part right here that you got to pay attention. I'm going to do this at the side of the paper, and it's going to put that 2x in front. You can do this in your head, but be really careful. That's going to be negative 6x minus 10. Okay, both of those signs change to negative because of that negative there. So that's going to be minus 6x minus 10, and then it's still over the bottom squared like that. Watch that part of the problem very carefully every time. Did I do something wrong? Oh, okay. Like I was saying, be real careful like the teacher just did. Okay, thank you. Okay, so that'd be a 10x like that. Is that better?
Yeah.
Okay, sometimes I can't talk and write at the same time. Okay, so we do that. Now what we're going to do is we got like terms. So you can put those together. So that would end up giving, that's negative 3x the second. Doesn't really matter what order you put it in. I kind of prefer to write it in this order. And then just leave the bottom squared. And I'll tell you a couple of things on this that you typically want to look at a little bit when you're doing the problem as far as simplifying. This is going to be the final answer to that problem. There isn't any other, I can't teach you a shortcut on that problem. There isn't any other way to do the derivative is to do the quotient rule. So you have to do that. So what you want to do on this is, and one thing I want to mention is you always want to leave this, just leave alone. Leave that denominator alone. There's never a time that you need to multiply that out. Just leave it squared. The reason is because sometimes, maybe like once out of every 50 times you do the problem, something will cancel. You can factor the numerator and cancel something from that denominator. It doesn't happen often, but it happens occasionally. So that's why I say just leave that alone. Okay, any questions? Having fun?
Yeah.
One person shook their head. That's pretty good. Okay, let's go to this next thing here. Then I'm down the next page. I'm going to do a couple more, then I'll let you try one of these and see how you do. Okay, so go ahead. What's that? I am finished. Yeah. What you would find on that is the numerator will not factor. You could try, but you would not be able to factor that. So you don't need to multiply out the bottom. You just always want to leave that something squared. You never need to multiply that out. Okay, you're done. Okay, so let's go ahead and let's put this together. Now see, this is ddt. The variables are matching. I'm just doing a different variable on this. So again, I'm just going to write down for reference. You don't have to write this down. Bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, so let's get it put in. Okay, just carefully write it in. So the bottom is 1 plus e to the t, close parentheses. Then I'll put times d over dt of the top. Okay, then minus, you just do it backwards. You do the top. And then you do the derivative of the bottom. And then the bottom squared like that. Once you memorize the rule, you'll get to where you can put that in the quotient rule a little bit faster when you do that then. So you want to get it set up. Then I'm going to highlight the two derivatives we're going to do. So the first step is get it set up, do those individual derivatives, then we do whatever algebra is left over. Okay? So let's see. Next step, you want to bring down the 1 plus e to the t. Okay, well, let's see if we can do this. Tell me what the derivative of 1 minus e to the t is.
Negative e to the t.
What?
Negative e.
Yeah, negative e to the t. The derivative of 1 is 0. You have that negative. The derivative of e to the t is itself. So good. That would be, I'm going to write that as times negative e to the t. Don't forget about the negative. Okay. Then the rest of the problem, we would still have the 1 minus e to the t. And what's the derivative of 1 plus e to the t? E to the t. Okay. All right. And then the denominator, I said a minute ago, always leave it alone. Okay. You do not need to multiply that out. It's a waste of your time. So that really is the calculus done. Okay, the rest of this problem is the algebra that we have to deal with. Okay, and what happens sometimes to students in these classes, I mean, you've done distributive property in FOIL, but maybe not with e's and logarithms and stuff like that. So it's going to look a little weird to you at times. So I'm going to do the distributive property here. So I'm going to do those two things like this. There's a couple of things we need to talk about as we do that. Negative e to the t times 1 is negative e to the t. Okay? But I want to focus you on this because I see students slip up on this a lot. I'm going to do this at the side of the paper. I'm doing e to the t times negative e to the t. What do you think that is? I thought somebody would say e to the t squared. That's the common mistake. It's not e to the t squared. 2t, good. Okay, it's 2t. See, the thing is, if you did something like x to the second times x to the third, that's x to the fifth, right? You add exponents. You add exponents on that. That's why it's 2t. T plus t is 2t. That's a common mistake I see from students a lot. So that's going to be minus e, whoops, not 2, e to the 2t, like that. That shows up. You got to think about your exponent rules and how they work. Okay. The next thing I'm going to do, and I'm going to also do this kind of at the side of the paper because this is another place that you have to pay attention to, is all of this stuff right here. You got that sign. I would kind of at the side, once you practice this, you'll be better at processing this in your head. But we're going to do the distributive property. So when I do that, and if you put that e to the t in front, it's a little easier to see. That would be negative e to the t, right? And then the next one is negative times negative is positive, and it's e to the 2t again. Okay, like that. So this is going to give you minus e to the t plus e to the 2t. You have to pay really close attention to your signs on these problems when you're putting these together. Okay. That's the step that I see students mess up on more often than anything else on a problem like that, is either the sign or that e to the 2t part. Is there any question about that? Okay. What do you see happening in the numerator? You do have a cancel, right? These two things are going to cancel. It's always nice that that happens. So what we're going to have left then is this. Those are like terms. So if you're doing minus 1 e to the t minus 1 e to the t, what do you think that is? It's minus 2 e to the t. Those are like terms. So that's going to give minus 2 e to the t. And then we got this. Then you are done. Okay, that is as simple as you can possibly make that problem. Again, you do not ever need to multiply that denominator out. Leave it alone. Okay, there's no canceling or anything you can do on that problem. Okay, you see the little algebra issues in there. Okay, be super careful, because when you're doing your homework, there may be times when you miss it just by a negative. You have to watch that sign and the quotient rule very carefully. Okay, any questions? Okay, I'm going to do one more, and then I'll put you to work and see how you fare on one of these. Okay, no choice on this but to do the quotient rule. So you have the top and you have the bottom, two functions. Okay, so this time I'm just going to kind of set it up. I'm not going to write down the formula this time. So I've got y prime. Again, I do the bottom. 2 plus ln x. You start with the bottom. You multiply by the derivative of the top. Then the minus sign. Then backwards. You do the top. Oops. Times derivative of bottom. And then do the bottom square. All right, as always, step one, put it in the formula. Okay, and again, usually the calculus part of these is going to be fairly simple for you. You've got to watch the algebra. So once you get that put in, then you need to focus on doing those two derivatives that I've highlighted, and be careful about when you do that. So the next step we would still have the 2 plus ln x. Okay, what's the derivative of 4x?
4.
How about the derivative of 2 plus ln x?
2. No, it's 1 over x.
What's the derivative of 2?
0.
0. What's the derivative of ln x? 1 over x. Okay, good. That's 1 over x. Okay. Yes, you're starting to learn rules. I realize you don't have all your rules memorized yet, but that's what you're working on. So that's what you do there. So this would be times 4. Then it would be minus 4x times 1 over x. Okay. And then we just bring down the 2 plus ln x squared like that. Okay. And the calculus is done. Okay. And it's generally not too bad to do the calculus. Now we need to just look at what type of algebra can we deal with here? So I'll show you kind of what I see. That is a distributive property right there. That's just simply distributing that 4 through that. So that's going to be 4 times 2 and 4 times ln of x. Okay, so if you do that, you're going to get 8 plus 4 ln x, like that. And that takes care of that. Now, if you look at this part right here that I'm boxing in, that is saying minus 4x times 1 over x. What is that?
Negative 4.
The x's cross out, don't they? So that's minus 4. Okay, so that's the algebra that would exist in that part of the problem right there. Okay, then the bottom, do I need to do anything with the bottom ever?
No.
Okay, I've said that several times because I see students doing that, and there's absolutely no need ever to multiply that out. Okay, only other thing I see, there's actually going to be 2 things you can do on this problem, is 8 minus 4 is going to be 4. Okay, so I've got 4 plus 4 ln x. Whoops, I can't write on this thing sometimes. So I've got 4 plus 4 ln x all over 2 plus ln x squared, like that. There's one other thing you could do. It actually wouldn't make that much difference on this if you didn't do it. Any suggestions about one other thing I could do? What are you saying back there? You're factor, take the 4 out. Good. Okay, you could. It wouldn't make any difference on this, but it's important that you always try that. You have a common factor of 4, so if you take that out, you would have 4 times 1 plus ln x. Okay? The reason it's worth doing that is because there are times when the denominator will cancel out. It doesn't there because you have 1 plus ln of x and 2 plus ln of x. So either of these 2 answers right there is okay. Okay, doesn't matter. Okay, but you do want to pay attention to that factoring when it shows up. Okay, any issue there? No? Okay, all right, go ahead and go for the next one. Go for it. Let's see how we do. Why don't you take it all the way to the bitter end and simplify it as far as you can. I'll write up the formula up here if you need to refer to it. When you get an answer, you might want to compare it and kind of see where we get on this. I think at the very end of this one, you may have a little factoring that goes on. What's this, that negative sign? That's kind of the key thing I like to look at. One thing you want to be careful about is make sure that's in parentheses. You may be okay with what you're doing, but you want to make sure that it's in a set of parentheses. Good. You have, that's good right here. I think you have an issue. The 2 times 12, 6 is 12. There you go. Keep going. See if there's anything. And that part right there, yeah, 3x cubed. I'm not sure what plus 3x is coming from. Because when you do the outside, that's just plus x. X times 1 plus x. Then you got that. That should be a plus x.
So I did that.
Well, that's good right there. Okay, usually that's the part that I don't see much trouble with. Let's see. What's that? You don't. Yeah, this right here, be real quick about that. That's minus. That negative is strictly square. That gets minus x. I think the other half is good. Let's see. Yeah, just see if you have any like terms you put together. One thing you want to have is you want to have parentheses around the x.
Yeah, that's what I got right. Oh, okay.
Around the x.
And then I
You need to
did
have certain parentheses there and there.
and then I got the x. So that's right here.
That's one. The derivative of x is always the number in front. Okay. Now see if you have like terms. I think you're doing okay. I don't see anything on here.
Right here. Because you need a derivative, there's 1.
Set up okay.
Because this will go away.
Make sure you have that in parentheses. Foil.
I think I messed up
No, your
here.
foil's wrong. So you have 3x squared plus x. Okay, look at that. That's minus 12x squared. Minus 12x to the second is what that should be. I think that's all it did.
But I guess it doesn't really change much. Just gotta change the sign so it doesn't combine with anything else.
3x squared plus 1.
The cancel.
You got that okay?
Which one's
I think there's some issues with parentheses and stuff. Yeah, you have an algebra problem in there somewhere. I don't know where.
I guess I hit it out. So then the x is completed.
You got it set up okay.
And
Double check your foil. And yeah, double check your foil. I see one issue there. And then I think that's it. That's what I'm seeing mostly is just a little algebra stuff here. I think you messed up on your algebra somewhere. See, look at this right here. That derivative is not this. It's 3x squared plus 1. 3x squared, right?
Mm-hmm.
So then I got
You have 2x squared.
Oh, okay. I don't know what.
Well, you know, that's all it takes. Got anything here?
Figuring it out.
Be okay. I have my answer here, and I closed my file accidentally, so I think you're on the right trail. Did you get something like that, or did you get something
I got
different?
something different. Because then I was supposed to.
I don't think you did all your FOIL. You have 3x to the third plus x. You forgot the plus x. See the first, outer, inner, last.
Yeah, but then I can remove this one, so then it would be negative.
Yeah, because what you have 3x to the third plus x. You should have a plus x right there. Not that, yeah, you can put it way over there now if you want to, but you didn't do all 4 steps from FOIL. That's all I see on your paper. It's just that part right there. I think you might be right. I'm not sure. I had my answer on there a minute ago. Okay, how many people finished? Okay. All right. I can't remember quite what the answer is. I'll go ahead and do it. What I'm seeing mostly is not using parentheses right. That's one thing that I'm kind of noticing out there. So let me go ahead and let's put it up. If you're still working on it, you can finish it up. But you'll be able, if you made a mistake, you should be able to see where your mistake is. So first thing, let's just make sure you got it set up. See, a lot of you aren't putting parentheses around x minus 4. You have to do that. You have to. Okay, and then we do the derivative of the top, and you have to put parentheses there. And then it's minus the top, x cubed plus x. And let me erase this stuff over here. And then it's going to be times the derivative of the bottom. And then it's the bottom squared. Okay, I can tell everybody's setting it up okay. I don't see anybody setting it up wrong. The only thing is use parentheses. Okay, because that'll cause you problems if you don't write things correctly when you're doing the algebra. Okay, the next thing you got to check is make sure you did your 2 derivatives right. Okay, so this is going to be x minus 4. This derivative is 3x to the second plus 1. See how I put a parenthesis? A lot of you aren't putting parentheses. And if you don't do that, you won't know that you have to multiply it out next. Okay, so do that. Then you have minus x to the third plus x. And then the derivative of x minus 4 is 1. And then it's all over x minus 4. So if you got to that point, you did the calculus correctly. Okay, that's the calculus is done once you get to that step. And the next thing I kind of saw on this was just some issues with signs and stuff. Now, what happened to my thing here? Okay, so now you got to check your FOIL. See if you did this right. So when you do this term, that's going to be 3x to the third plus x minus 12x to the second minus 4. So that's what you'd have on your FOIL. Okay, now notice on this, what does this negative do? This is the big mistake I see all the time. What does that do? Changes both signs, right? Okay, so be careful about that. You should have, when you do that, you would have minus x to the third minus x, like that. Okay, then you would have x minus 4 to the second. So if you got to that step there, you probably got the right answer, unless you made an arithmetic mistake. So what's going to happen here is you have x to the thirds are like terms, so that will give 2x to the third. You should have that. And then we have the x's cross out. Okay, no, I think, yeah. Is that right? Yeah. Okay. Then I have minus 12x to the second minus 4 over x minus 4 to the second. It turns out if you got that, that's a good answer. Okay, you can factor also. Okay, how many people got this? Okay, that's not too bad. Okay, I know you were about to get that. Okay, that's pretty good. Now, see what you want to do from here is you want to go ahead and you can factor a 2 out. You want to always try this. It won't make any difference on this problem, but if you took a 2 out, you would end up with this answer, but nothing's going to cancel. So it's like either answer is okay, right? But it's always a good idea at the end to try to factor and see if something will work out of the problem. Okay, I did pretty good. Do you guys see where if you made a mistake where it was? Okay. Use the parentheses. That's the number one thing you want to learn from that. Okay. Okay. All right. Well, let me move on to this next thing here. We revisit this tangent line thing all the time in this class because that we're working with tangent lines when we're working with derivatives. The only difference with this problem is going to be that you're going to have to use the quotient rule to put this together. So what I'm going to do on this one is, since we've done this problem so much, I'm going to kind of take you through what you want to do and let you work on this a few minutes yourself. The first thing that you want to do is you're going to need to do the derivative of that function. Okay, you're going to do that with the quotient rule. Now, I'm going to let you guys work on this one yourself, and I'll see how many people can get through this okay. The second thing we've always been doing, when we find an equation of a tangent line, what do you ultimately do? What gets us to the answer finally? The point slope formula. Okay, all right. So what you got to do next is, let's just write this down. And what's going to happen on the problem is, see, I've given you everything that you need to know except for one thing. I've given you the point. Okay, so you know that the point, the -1 plugs in there, and then the -2 plugs in there. What do you do to get the m? You do what? Derivative. Okay, right. You do the derivative, which is quotient rule. And then what do you do after you get the derivative? You plug the x value in, right? Okay, so you want to do that. Okay, so go ahead and start with this. Go ahead and get your derivative and see what you can finish up on that. Okay, then we're going to look at this one graphically on the calculator in here in just a minute also. So go ahead and see what you can do. Okay, go for it. Do the derivative. That's step one. You got to get your derivative right. Then plug the -1 into your derivative when you're done with it. And we'll see if we can get this one okay.
Was.
I'm going to shut the screen off for a minute, and I'm going to go ahead and kind of quickly work it out and give you a little time to run through it. What you want to do when you get your derivative, you probably want to check with the person next to you and see if you're on the right track. Because if you miss the derivative, it's going to mess everything else up.
It's extra.
What's that? Yeah, you got to do the quotient rule. You have no choice.
So you put the x value in, and you press the derivative, and then you put your 6.
Has anybody done the derivative yet?
Yes.
Did you get that?
Yeah.
You did? Somebody say yes? Okay. Look through that. Okay, that's what I'm getting on the derivative.
You saw the -2 or no?
No, you plug in the x value. The x is, the point I gave you is -1. So now that you get that derivative, then you plug the -1 into it to get the slope.
But it would just be 2. Oh, okay.
Sign issue?
Well, because then there's still
Did you get that?
Because there's still a -2x.
Yeah, -2x.
That's, I hope I didn't mess up.
Because that's all we're just that's all we're missing. Yeah. Or I guess that's what we have extra.
Did anybody get my derivative? Seriously?
No.
Okay. Now I'm worried that the teacher did it wrong. Okay.
You just forgot one thing.
Maybe I did
You
forget
just got,
something.
2x in the middle.
Tell me what you're getting.
X squared minus
It's
2
just-
minus 3.
What the heck did I do? Okay, maybe I just wrote something down wrong on here.
Because I'm getting positive x squared. I'm getting positive x squared. So yeah, minus 2x minus 3. Yeah.
2x squared. Okay, now the teacher gets it.
Let me see if I
Okay.
actually got the slope right. Oh, so it's -5. -5. Sorry.
Did you get x squared minus 2x minus 3 in the numerator?
Yeah.
There we go. Okay, gosh. I was trying to help you out.
I teach it this actually. The slope. Yeah.
Okay. Okay, now you should be able to go through and see if you can finish it. So I'll give you a few more minutes to see if you can finish it. Now what do you do to the x's? Plug in -1, right? You got to evaluate it -1 because I'm giving you the point -1, -2. Okay? So you would get to that point right there and find that. Just be careful with your arithmetic when you do that.
Breaking the y value is -3. Because then you need to plug in the -1 is the original quotient. Okay. That's 1.
What did you get when you plugged the 0? Hold on, I just gave you the answer.
That's
What happened when you plugged the -1 in?
2.
Yeah, okay, all right. The teacher is not feeling confident for some reason. Okay, yeah, you would have got 0 on that. That actually makes getting the answer pretty easy on this then. And then what I'm going to do with this one, I'll display up here what I got, and then I want to just finish this up on the graphing calculator. And anybody get a final answer? Y equals -2? Yeah, that's what you should get. Y equals -2. Yeah, okay. So I'm going to put up here a couple of things. On here, this will come up here, and then we're going to finish up by doing the graphing of this. These are kind of the key things. It's a little messy up here, but the key things are you want to make sure this is the derivative. I wrote the derivative on the board. Okay, then I plugged in -1. I plugged in -1 because that's the point I gave you. Okay, when you plug that into the derivative, -1 squared minus 2 times -1 minus 3, you end up getting 0/8, so you get 0. Okay, that's the big work of the problem, is doing the derivative so you can find the slope of the tangent line.
You did cube on the bottom.
-8, doesn't matter, I'm lucky, aren't I?
Yeah.
Okay, so that's 0/8 is equal to 0. Okay, so we got that. Then when I plug this in, I'd have y minus -2 equals 0 times x minus -1. Yeah.
You don't cube at the bottom instead of square.
Tell me why the teacher is cubing that.
think that's how you got 8 too.
It doesn't matter. I'm lucky, I guess, on this, but that should be squared. That's bottom squared. So you would end up getting 0 over 4 is equal to 0. Well, I just lucked out. Okay, but you got 0, right?
Yeah.
Okay, all right. So now what you do on your final answer is you'd have y plus 2 equals 0 times x plus 1. That whole side crosses out, so you would end up getting y equals negative 2. That's what you'd end up getting, okay? All right, a lot of work on this. Now get your calculator out because I want to finish up just class by doing this one last thing on the calculator. Let me put this over here. Okay, so we want to go ahead and you want to put this in y1. Let's put the function in that we just did. So we did x squared plus 3 divided by, then we had x minus 1. So what I want you to do is I'm going to have you do graph this on your calculator. That's the function that we did. And then put in y equals negative 2. The answer we got was, the tangent line was y equals negative 2. And then we'll just try to do that in a standard window, and then I'll have you, mainly we want to visually see if this looks right to us. Okay, so get that put in, and then just do your graph, and we'll see what it looks like here. That one you need to do zoom 6 on that. So zoom 6 to do it, put it in a standard window. Well, let's see if that looks right. So on my graphing calculator, the blue is the function, right? Okay. Does that look like it's a tangent line to that point? Okay, yeah. Okay, so visually you can tell that it looks like we did the right thing. Okay, because what you're doing is if you trace at negative 1, that's what we found on the problem. It was at the point negative 1, negative 2, we found the equation of the tangent line. So it's right, okay? You can visually tell when you do these problems if it looks right when you graph it. Okay, does that look okay? Okay, all I want you to do on your graph, and then that'll wrap us up for today, is just put the negative 1, negative 2 point on there, do your tangent line, and then the rest of it, you know, just for your notes, you can just kind of sketch what it looks like. It doesn't have to be perfect. If you have that part, that's good enough. All right, because that's what I wanted you to see anyway, okay? All right, so it looks like we did pretty good with the quotient rule. I think we're doing a pretty good job with algebra and everything. That's what you're going to deal with when you work out problems, is careful with the algebra. Okay, so I'll be upstairs the next 2 hours if you need any help with anything.
Can I swing by about 1:30?
Yep, that's fine. I'm in my office the rest of the day.
Okay.
That's fine.
All right, sounds good. I'll see you then.
I'll just text you, like, on Monday or something. Have a good weekend. You as well.
All right, you too.